In this video, we'll be looking at last year's June paper 2, question 10. So we're given this diagram here, circle with a cyclic quad. TR is given as the radius of the circle. We are told that PK is equal to TK. And we are told that chords TP and KR extend to create point S, to meet at S. Right, that is all the information we are given. So the first thing we're told to do, prove that SR is the diameter of circle that passes through PS and R. So how do we do this? Let's start with finding this angle here. Right, so it's angle TPR. Sorry, your angle's actually on top of the P. Because this is a diameter here, we can immediately say it's 90 degrees. Angles in a semicircle. Furthermore, P3 right here should be 90 degrees because of angles on a straight line, right? TPS is one straight line. And just like that, we can already say that SR is a diameter. The reason we can give is conc angle in a semicircle. Right, it's because that is 90 and that is 90. And we're creating a semicircle here with that as a diameter. Right, hope you're seeing how that logic works. So that's 10.1.1. Here's my cloth. Let's look at 10.1.2. That asks, 10.1.1.2. That asks us to prove that angle S is equal to angle P2. Use a different color here. So we're trying to prove those two equal. Now the way to do that, let's start with angle R1. Equal to angle PTK. PTK, that one there, is equal to angle R1. Why is that? It's the exterior angles of a cyclic quad. Furthermore, angle P1 is also equal to angle PTK, this time because of exterior angles of a triangle. PTK forming there. Sorry, not exterior angles. I've got myself confused here. It is right. Angles opposite equal sides of triangle. Right? Because these are equal sides of one isosceles triangle, these two should equal to the same amount. Okay. So because of that, angle R1 is equal to angle P1. Great. Also, angle S plus angle R1 should be equal to angle P1 plus angle P2. Reason for that is exterior angles of a triangle. Sorry, that's where that part comes in. Which means that angle S plus angle R1 is equal to angle P2 plus angle R1. Therefore, angle S is equal to angle P2. Just proven. Great. So that's 10.1.2. Let me erase quickly and we'll do the final part of this proving process. Okay, now they want us to prove that two triangles, SPK and PRK, are similar. Right, remember when you're doing a triangle proof, you follow the same formula every time. So in triangle SPK and triangle PRK, let's find the first things that are similar. Well, we've just proved that angle S is equal to angle P2. Proven. And if we look at these triangles, SPK, PRK, this angle here, this K2, is shared between them. So, angle K2 is equal to angle K2. Sorry, shared is not the correct terminology, it's common. Right, it's a common angle. Now, SPK should be 180 degrees minus angle S minus angle K2. Alright, that's interior angles of triangle. Similarly, PRK should also be 180 degrees minus, what's angle P2 minus angle K2, interior angles of a triangle. Right, so we've proved that three angles are the same as each other. Therefore, triangle SPK is similar to triangle PRK. Reason, angle, angle, angle. Alternatively, A. Alright, we have proved the three things they wanted us to prove. I'm going to pause, erase, and we're going to go on to 10.2, the final question of this paper. Right, okay. So, question 10.2. It gives us a little bit of extra information. They say that SR is equal to RK. Given that, prove that ST is equal to square root 6 RK. Okay, so here's how we're going to go about this. First, we can say that PK over RK, PK over RK, is the same as SK over PK. Reason being that these two triangles we just proved are similar. Triangle PRK. Right, they're equivalent sides. Right, let's rearrange this a little bit. Let's times both sides by PK, so that makes PK squared over RK is equal to SK. Divide both sides by RK. PK squared equals SK over RK. Great, that sets us up nicely to then do a bit of Pythagoras. So let's consider ST, SK, and PK. Sorry, and TK. That makes more sense. Yeah, so we can say that ST squared is equal to sk squared plus pk squared. Reason? Pythag. Right, st sk. You can see because of our multiple right angles, because that's a right angle, this should also be, it becomes very, very easy. There's lots of places you can do Pythag. This, I think, is just the easiest place to do so. But tk is equal to pk, that's a given. Y equals tk, pk. It's given very early on. So we can say that st squared is equal to sk squared plus right, sorry. You can see how my notes confuse me a bit. Right. St, sk, and tk. Because we did the Pythag, because we know this has to be a right angle, because that's a right angle, it's opposite sides of a cyclic quad. Right. You can do a bit of proving in between here, if you want, right? Angle TKR is equal to angle of TPR is equal to 90 degrees. That's because of angles. Cyclic quad. Right. In any case, once you've done that part, from here things should be quite nice, because pk squared, we've already defined it separately. So st squared is equal to sk squared plus sk over rk. Okay. But, right, so we have also further information here. Sk is this line. We can see very easily this line is made up of these two lines, right? And also we've been told that SR is equal to RK, that was given. So, I'll just draw a line here. Because of that, we can say the following. Sk is equal to 2RK. Now, st squared is equal to let's place 2RK squared plus 2RK over RK. Yeah. Oh, sorry, it's not let this thing fall too far back. There we go. Therefore, st squared equals 4RK squared plus where have I misled? Give me 1 second to make sure. Right, my apologies. The issue here is that wasn't supposed to be divide. and you I hope you caught that early on, because I did catch it when I did this work, and then I didn't catch it when I was explaining it. Unfortunate. But what that does is, it's not divided, it's supposed to be a times. So when we exchange that sk for 2rk, over here it becomes, 2rk times rk. In other words, 2rk squared, which means st squared is equal to 6rk squared. Square root both sides. St is equal to the square root of 6 times rk. We have proved what they wanted us to prove. So it's a bit of a long proof. It's a bit longer if you make a mistake like I just did. But the fundamentals of it are, you use your similar triangles. You use some Pythag, and then at that point you're just switching out different sides for each other until you're left with just st and rk, because that's what you have to prove. Okay, sorry if that one was a little bit confusing, but I hope that can help. And that's the end of 2023 June paper 2. Good luck.